Hello, I'm Liao. Welcome back to Evan of Code 2023. We are solving programming puzzles every day and we are today at day 10. We have done 9 days and this is the 10th day. So let's take a look at what puzzles awaits us for day 10. Day 10, Pipe Maze. You use the hand glider to ride the hot air from desert island all the way to the floating metal island. The island is surprisingly cold and there definitely aren't any thermals to glide in, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing into a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien, even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you have seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you are standing on is densely packed with pipes. It was hard to tell at first because you are at the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see, which is your puzzle input. The pipes are arranged in two-dimensional grids of tiles with a vertical, horizontal 90-degree bend. J is a 90-degree bend northwest, and this is the ground, right? So this turns from coming from the top to the right. This one comes from the top going to the left. This one connects from the left to the bottom. This one from the right to the bottom. And S is your starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what the shape the pipe is. Based on the acoustic of the animal scurrying, you are confident that the pipe that contains the animal is one large continuous loop. For example, here's a square loop of the pile, right? So this goes to the right, go down, and then go to the left, and then go up, and then come back. If the animal has entered the loop in the northwest corner, the sketch would look like this instead. So here's the animal. In the above diagram, the S tile is still a 90-degree F bend. You can tell because how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. So the sketch shows the loop as same. We still have this, but we still have a lot of unrelated pipes connecting with each other. In the above diagram, you can still figure out which pipes form the main loop. They are the ones connected to the S, pipes those pipes connect to, pipes those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will exactly have two pipes connecting to it. Exactly the same, and which assume connect back to those two pipes. So here's a sketch that contains a slightly more complex loop. Let me try and see whether I can draw it out. Right, so here it looks like this, and then come here, and then goes up, and then goes like this and connect. Right, so it's a loop. Right, even like this, it is in a L, and then I turn right, and then down, and then left, and then down. Right, so it is a loop. So if you want to get out ahead of the animal, you should find a tile and a loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find a tile that will make the longest number of steps along the loop to reach from the starting point, regardless of which way the animal went. So in the first example of the square loop, right, you can count the distance each tile in the loop from the starting point like this. So you can go either from the left or from the bottom. And in this example, the farthest point from the start is 4 steps away. Here, a more complex loop again, so it's the same as the loop just now. Here, the distances from each tile from that loop, right? So we go up 1, 2, 3, 4, 5, 6. Here, 1, 2, 3, 4, 5, 6, 7, 8. So the giant loop starting as S, the longest distance is 8, right? So now, given with our puzzle input, how many steps along the loop does it take? to get from the starting position to the point farthest from the starting position. Okay, interesting. So let's start coding and let's try and figure out. So let's go back to our code. I am at day 10 with our puzzle 1. So I have all this code stored on GitHub. You can find the link to my GitHub for this repository on the description below. And now we are at day 10, puzzle 1. Let's start with our inputs. Let's just use one of the example input over here, like this one, to just test out our idea to see whether we are on the right track. So the first thing is, this is a string with new lines, and every line you have the tiles. So I'm gonna split it out into an array, like making a matrix out of it. So first thing is, I'm gonna create the map equals to input split by new lines. And next thing is, we need to find out where S is. So this is our starting point, right? So I'm going to create a function called find S to give us the starting point, right? So this is the starting point equals to find S. So the find S, basically what it does is that it will loop. So every row we start with 0, row less than the map dot length, and then like column equals 0, column less than map row dot length. So here interesting thing is that we just split by new line, so every element in the array is a string, but string also behaves sort of like an array where it has a string and you can still, so it has a length and you can still index the character by, you can find the character at the specific position using index. So it just feels like an array, and you can we are gonna treat them just like an array of characters. So here we are iterating through like the same way, right? Row and column, and then if map row column is equals to S, then we found where our the starting position is. Then we're gonna return row column, okay, like this. So so you don't have to worry about what happens if we go through the finish the for loop but we don't get anything, because there will always be an starting position over here that's guaranteed by the map itself. So now we already have our starting position. Now next thing is, we need to find out the length from furthest from the starting position. Okay, so the thing is that it can go up, down, up, left, up, down, left, right? So there's 4 positions that you can choose, but there's only two tiles neighboring up, down, left, right that is connected to the current tile. So we need to find those 2 out, right? So I think the way that we can do is that let me see. I'm going to create an array. Okay, and then I'm gonna loop through the up, down, left, right position to make sure that we to find if up, down, left, right is connected to the S, then we'll push into the array. And then hopefully we get only 2 elements. I think that's guaranteed by the input itself, so we don't have to check for that. But let's try to loop through the up, down, left, right position first. So we have the row column equals to a of. So over here we're gonna try a few position, right? So the up position is actually row, is the starting point, row 1 up row minus 1, column is starting point dot column, right? This is the up position. The down is actually the same, but the row is one more row. And we have left and right. So left and right, in this case, the row is the same, but the column is basically -1 or +1. So this is to the left, this is to the right, right? The column is vertical, right? -1, +1. So for each of this row and column position, we check if it's connected to the starting point, right? So let me see, how do we know whether it's connected to the starting point? Oh, it's a bit. It's a bit tricky over here. I think for the starting point, I think let's try to maybe write a few codes to make sure that it works first. Rather than having like a very abstracted kind of for loop. Let's see. I think, right, if it's in the top over here. Right, so if I say if the map, I want this column, right? I want this column. And the row is like this. This is the up tile. If this, so for the top, right, what can connect downwards for you is either the one that can connect at top. If it's connected to you, it can be either the vertical pipe, the 70-degree band, and the 90-degree band, right? So it's from bottom going up to the left or the right, right? So if this one, the 7, and the F includes this one, then in this case we know that we can connect it to it. Then array dot push. I'm gonna push this over here, right? Column, row. Why my row is here? So it should be row on column. Yep, this is going up. And then going down is similar. So going down is rows +1. Down. Then we can either go down by with a pipe or with a L and a J join. Right? Going L or J. And this one. And then we have left and right. Left and right. I think this one, this is -1, +1. This is +1 for the right. Okay, and for the left, what you can connect is the dashes, right? One dash for the horizontal. And then we can turn left from the right. If it's on my left side, right, I want to come from the right and then turn up, or the right thing down. So it's L and F. And then from the right is either coming from the left, and then it goes down, which is the 7, or it go up, which is the J. 7 or the J. Right. So by now we probably will have an array of 2 positions that we can start to start continue traverse. Right. So here, just trying to make sure that we are on the right track. We haven't been printing out the logs in between so far, but let's try and see. So let me run this day 10 puzzle 1. We have 2, right? Basically this 2 tiles connects to my starting position, and we're gonna start from here to traverse out and see what's the distance until from the starting point until we reach the end of the when we meet each other, right? So we're gonna start from here. I'm gonna use something like a breadth-first search, keep finding outwards until we reach the end, and then that's the meeting point, and then we'll know that what's the distance from that point, how many steps that we have moved, and then that's the point that we have arrived at. So I think first thing is, as like breadth-first search, as we traverse, we're gonna make sure that we don't step back to the same tiles that we have been at. So for that, we are going to create a set called visited to mark which tile that we have already visited. So we can store tiles or any data structures that we want in a set, but in this case for us, we're gonna just store a string of the position with column, a row, comma, column, right? So we're gonna initialize with a few elements first. First is the starting point. So this is the starting point dot row, comma, starting point dot column. And then we're also not gonna visit this the 2 elements in the array. So we have the array 0 dot row, comma, column, and then we have the row 1, comma, column. These are tiles that we have already visited. We don't have to visit them anymore. And so from here, since we already step 1 step out, our step is equals to 1, right? Let me think. Should I do that? I think we don't have to have that. Let's keep it in here instead. Probably it will be much easier. So distance is equal to 1. Right? So later on when we're gonna take an element from the array and we're gonna try to find the next position that it can travel to, and then we put it in with a distance plus 1 of what the current distance is, and then in the end we have the distance, the furthest distance that we get, and that will be our answer, right? So so right here, let furthest distance is equals to 1 for now. And so furthest distance. Okay, so now next thing is, with this array, we're gonna do a depth first search. So the pattern of a depth first search is that we'll take one element out from the array one at a time, right? So this is how I will take it out. I will shift out one element, right? Shift is basically taking one element from the front. So this is we have the column, the row, and the distance. Take one element out from the array, and then we're gonna find column, row, distance, column, row that it can traverse to, right? And then if the let next column, next row that it can go to, and if visited this has this is next row column. If we haven't visited this row and column, what we're gonna do next is we're gonna put we're gonna push this column row distance. We're gonna go to this next column, this next row into our array that we will gonna explore next. We're gonna push it into our array, and we just continue the loop until there's no more tiles to explore. Right, so while array.length is greater than 0, or you can I think any non-zero, non-positive non-zero value, while that value is always true, so we can also simplify with this. But let me just keep it like this first. And then and over here, I think actually I can add one more line. Furthest distance is equal math.max furthest distance, comma distance. So this is the furthest distance that we can explore to. And then since we're going to explore it over here, we are also going to add this into the set that we have already visited, right? So we don't step into this tile again the next time. So here is the rough structure, right? And at the end, what we need to do is we're going to console log out the furthest distance, which should be our answer. Of course, you might wonder, like, how do we know what is the next column, next row? Then basically that's what we are going to do right now. We're going to figure out what is the next row and what's the next column. So it depends on the current tile, right? So the tile is equals to map row column. Okay, since the map guarantees that it will form a loop, then which means I guess that we don't have to worry that it will have any index out of bound kind of situation, since we are just keep going, traverse the next tile within the loop, the pipe loop itself. Right. So where we're gonna go next, it depends on what the value of the tile is right now. So possible position, and because one tile kind of connects to two possible tiles, two possible next positions, then I'm going to create an array called this one, right? And then we are going to check based on the current tile, decide what are the possible positions. And then for here, basically, we are going to loop through all the possible positions and determine which one we can go next from here. Right, so this part, this logic over here, I think we can extract it out to another function. Find possible, find next possible position. Given that we have a row, a column, and the current tile. Right, we switch based on the this should return the possible positions. So we're gonna switch. Here we are going to replace this by this instead. Row, the column, and the tile that we have. Then we can remove this unnecessary code over here. Right, so here we have the switch statement, and let's see what are the different types of tiles that we have. Right, I think possibly we have since it's a loop, we probably won't get into the ground, so we can ignore this ground. And it's either these few types of pipes. Right. So we will start with a case And then we're gonna see what are the possible tiles that we can get go from here to there, right? So if we're gonna have a vertical one, then basically our next positions could be row is the row plus 1 with the same column. The row is equals to row minus 1 with the same column, right? So this is going up or going down. I think we don't need the possible solutions variable here since we can return directly like this. So let me remove this over here. Then for the horizontal one is it's kind of similar. It's going to the same row, and then the column is actually column plus 1 or minus 1. For L join, what we can have is we can either go up, right? Going up, which is the row equals to row minus 1, up 1 row, staying in the same column. Or we can be the same row, but we're going to right, which is column plus 1. For J instead, we going from up to the left. So we can either going up, it's the same, going up. And then this one, we go left, so it's the same row, but then column, we're going to minus 1. For 7, we are going from the left or going down. So going down is row plus 1 with the same column. Going left is basically the same row but column minus 1. And for F, we are going from to the right. So it's the same row, but yeah, and the column plus 1. And going down, which is the row plus 1, staying in the same column. Right, so we have this all possible positions based on the current tile and based on the current row where we're going to go to. Then over here, we are looping it through and then find the next row and column that we're going to, and then we check whether we have been there. If not, we're going to go there, increment the distance, and we also make sure that we don't come back again, so we add the visited over here. And then we just keep going to explore what are the possible tiles until we don't have possible location that we can go to. Then probably we have exhausted through the whole loop, and then we basically find the furthest distance that we can travel based on that. That will be our answer that we're gonna print it out. And so let's try to run our code. And fair enough, we had 4. We get 4, which is the answer for this one, right? This is the loop. So this is the answer is 4, which is correct. So let's try our actual puzzle input. Wow, this is a huge map. Let's copy this and let's see whether we can still run perfectly with this one. And we get a number. That's fast. Let's copy this. Let's come back. Let's paste our answer in and let's hit submit. And it's the right answer. Yay! We get 1 more gold star and we are up for the part 2. So continue to part 2. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe it's within the area and close by the loop. To determine whether it's worth taking time to search for such a nest, you should calculate how many tiles are contained within the loop. So above loop and merely encloses merely 4 tiles. The 2 pairs of dot in the southwest and southeast. So these 2 dots. In the middle distance marked by 0 below are not in the loop. Here is some same loop again with those regions marked like this. Okay, so this is complex. So here this is the loop, right? So basically whatever it's inside the loop, it is, you count those tiles, and outside is not, right? Like this. In fact, that doesn't need to be a full tile path to be outside for the tiles to count outside the loop. Squeezing between pipes is also allowed. Here, I is still within the loop and 0 is still outside the loop. What does it mean? In fact, that doesn't need. In fact, that doesn't. Is there a difference between these two? No, right? Okay. In fact, there doesn't need to even to be a full tile path to be full tile path to the outside of the tiles. Ah, okay. So even for this one, because this one has this one, you see, it has tiles that connects to the outside world, right? So this is definitely inside. But this one, the zero part is not. It's not within. It's not connected to the outside, but uh, it's still considered as outside of the loop. Okay. In both examples, four tiles are enclosed by the loop. Here's a larger example. Wow, this is fairly complex. Let's try and trace. So let's start with S, right? S comes here, goes down, goes this loop, go here, go here, go here, go here, go here. Okay, so far we're not enclosing anything yet. Go here, go here. Did I miss anything? I think I did not. Then come down here and then come over here like this, like this. Hold on, I think I traced it wrongly. Where did I go wrong? Okay, so S goes to J, F, L7, like this, like this, like this. That's correct, like this. And then, hold on. Oh, like this over here. It doesn't go all the way up. So like this over here comes here, comes here, comes here. J F7 LJ F7 J here 7 L7 L7 J L7 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 up here 7 L7 down 7 F1J up and then S. Okay, now so basically this is our loop, right? This is the full loop that we have seen. So basically what is enclosed within this loop, I guess, are tiles in between. Tiles in between is just this few. Huh. Interesting. Because um so we only have 8 tiles enclosed within the loop. So even we have, let's see, I guess from here although it seems like we have enclosed quite some tiles over here. For example, we have, let me zoom it out and visualize this one. So we have from the starting point, we have coming from here. Right, we have over here. Wait, 7LFJ. Something that looks like this. So I guess this point is not part of the inside. And here, this field seems like gonna be considered as this field feels. Seems like it is inside. right? These few dots over here seems like gonna be inside. So you have 1, 2, 3, 4, 5, 6, and then probably this one that's surrounding it, it is considered as inside as well. So we come here, up, down, one loop, right? So this is considered inside as well. I think switch color. I think this one is considered inside as well. These are all outside, right? This is outside. This is considered outside. So if 1, 2, 3, 4, 5, 6, 7, and 8 of them, right? We have 8 of them. How do we even know what is considered inside and what is outside? Like, what is the algorithm that we need to have to figure this out? Right, I think one way is that we can calculate first is that we know what are the tiles that is a pipe and what are the tiles that is not the pipe. And then secondly is that we will need to calculate how many boundaries does it crosses. That's usually to differentiate whether you're inside or outside, right? So for example, this crosses one boundary to go outside, then it's probably inside the loop, right? This crosses two boundaries, 1, 2, then it's probably to reach all the way to the outside world, then it probably is considered as outside. Because if you're inside something, right, you have to go one step to be going to the outside. Or rather like odd numbers of boundaries that you need to cross to go to the other side. This is considered as being inside. But if you are having something like this, right, you are here, then you cross two boundaries all the way to the outside world, then you are actually outside. I think either side, like you see, you are crossing boundaries and on an odd number, even number of times to get to all the way to the outer boundaries, then you are considered as outside. Even if you look something like this, right? Like you have to, if you are here, you cross 1, 2, 3, 4, which is even number to all the way to the left edge, then you are still considered as outside because you yeah. And if you it's even number of edges, but if you are like in this case and you are here, you cross here 1, 2, 3 even number of times, or cross here even number of times to all the way to the right edges. Cross either side you are even odd number of edges, then you are actually considered as inside, right? Because you cross once, you're going to the other side, right? Outside or inside, and cross another line, you flip it back. So you by crossing it this way, then you can calculate how many times you cross the boundaries. You roughly can know it's even. If it's even, it's outside. If it's odd, it's inside. And we're gonna use one dot and cross all the way to. We're gonna use it to cross to figure out like all the way to the left edges. I think on any side of the edges, then we can see that whether we are actually considered as within the inside or the outside of the loop. Okay, I think that's the rough idea of how I'm gonna solve this. Any pile that is not main loop considered and closed by the loop. Here's an example of many bits of junk pipe lying around that aren't connected to the main loop at all. Here are just the tiles that are enclosed by the loops marked by I. Right, so it considers these are the one highlighted like this one. So it also considers those tiles that is those tiles that are not just ground, it could be any pipe, right? In this last examples, 10 tiles are enclosed by the loop. Figure out whether you have time to search for the. So now you have 10 tiles, right? So to figure out whether you have time to search for calculating an area within a loop, how many tiles are actually enclosed by the loop, right? So this have 10 tiles over here, and how many tiles that's enclosed by the loop? Phew, this is definitely tougher than just finding the location, but let's nonetheless try our best to see how we can solve this problem. So we're gonna copy this to puzzle 2, and we are gonna clear our input first. We're gonna try out a simple example first. A simpler example in this case would be I think this one, right? And I'm gonna replace all the zeros to dots, this all to dots, and then this should gives us answer called the answer should be 12, right? No, 4. This are the only one that's inside the loop. Okay, so we need to figure out how many tiles that is inside, right? So let's try and run this, and let's think about how we can write this. First of all, I think the logic that tries to find the pipe loop, the one that we just had in the puzzle one, I think that logic we can keep it, right? Because since we still need to know what is the loop anyway, right? So which means most of this code over here can be kept. And actually the visited itself, the visited sets that we get in the end is actually where the loop is, the boundary, the tiles that has the pipe that is part of the loop, and anything else is not, right? So I think this one we can rename it a bit to call it the pipe, right? Or rather the pipe loop. This will contain all the tiles that is on or within the pipe loop. So as we go through, I think one thing we don't need is that we don't need to know the distance. The furthest distance, this is something that we don't really need, right? The distance for each tile is something that we don't need. So this part I can remove. We can still keep, I mean, it's not going to use anyway, so we're going to remove them. So after removing the distance, the logic of calculating the distance over here, like this one, we're going to trash them as well. This one, I'm going to trash them. And then when we push, also no more distance. Let's remove them. Nothing to do with the distance anymore. And I think this part, the logics can be kept. We can keep it like this. So basically by the end of the array, or by the end of this traversal, what we're going to do is basically here, if you try to console log out the visited, this will give us the list of tiles, hold on, not visited, the pipe loop. The pipe loop. Save this. Is we're gonna run this, then we'll get a list of tiles position row column for where the pipe loop is in, right? And so then next thing is we're gonna go through tile by tile, right? Go through tile by tile and then determine whether the tile is within the loop or it's outside the loop. If it's within the loop, then we're gonna increment our count, and then if it's outside the loop, then nah, we're just not gonna do anything. And then that will be the answer, which will be the count of number of tiles that is within the loop, right? So here we're gonna increment, define the variable first, tiles within the loop is equals to 0, and then we're gonna loop through tile row equals 0, row less than map.length, row plus plus, And then same thing for let column equals 0, column less than map row dot length, column plus plus. And then we have and then we are looking at tile by tile and determine whether this tile is within the loop. I think first of all, we are going to have another flag called is in loop. We're going to start with false, because the first tile we're going to look at is probably most likely is not within a loop. And then if we crosses a boundary, as we said earlier, if we come in, like for example, as we traverse and we crosses a boundary, then we will gonna flip this flag to tell us that we are in the loop. And so we wanna have this flag every time, and then to tell us whether we are in or we are out of the loop. And if we are in the loop, then and we encounter something that is not a tile, then I think we can increment a count, right? So the logic will be something like if the tile is equals to row, comma, column, right? This is the key that we actually store inside the pile loop set, right? If tile is if pipe loop has tile, if it's not, if this is not the loop, and then if is in loop, then we are going to tiles within the loop plus plus. Right, we're going to increment, and then lastly, what we need is going to print out the tiles within the loop. Okay, and if it's not in the loop, if it's not part of the tiles that has the pipe loop and it's not within the loop, then we don't do anything. Okay, but of course, if we are in a pipe loop, then we need to figure out the logic of whether we're gonna flip, when we should gonna flip this is in loop variable, this flag. And since we're gonna check row by row, I think every row, even like if this one, since we're going row by row, right? So from the leftmost tile, we actually are going to reset back the flag to be false, because at the beginning of the row, we probably is not got the state of it, and the state over here probably is not related, right? The first tile in this row compared to the last tile of the previous row probably not related. So here maybe we define this variable within the row, we initialize it to false every time in each row instead. Right, so here now is our logic to determine whether we are crossing the boundary and then we are going into the loop, or we are still outside the loop, right? So if we already encounter a tile, right, then basically there's a few situations what the tile looks like. Okay, so since we're going to row by row and then we look at every column tile, we focus on the vertical tiles, because as we cross a vertical pipe, then we are in the loop, and then we cross again, then we are outside of the loop, right? So the vertical tile, if it passes this, then which means we are actually we're gonna flip this flag, right? So here, else in this case, if it's part of the pipe loop, right, then in this case, we're gonna say the I think we're gonna call a variable called tile again. Tile is equals to the map row column. I think this one, let me just put it here instead. It's not confusing. So this one, the tile, and then we're gonna switch the tile and then determine, right, the logic. So this is actually similar to like this over here. And case when I say we do the pipe, then we actually is in loop. It's gonna be is in loop. We're gonna flip this flag instead. Okay. Then there's quite a lot of different types of tiles, right? So we're gonna copy all the situation over, and then let's take a look at what we should do in each case instead. Right. So when we are in a horizontal bar, right? Horizontal bar, I think it doesn't matter if at this point you are in the loop or outside the loop, it doesn't really matter anymore because it's not crossing any boundaries. And in fact, I think when it's more of it depends on actually on the left or right corner whether we go turn it down or turn it up, right? So actually, if we look at row by row, right, it's actually when we know that we are crossing a border, is basically we have a tile that connects from top to bottom, right? As you can see here, we want to cross this border to go into an in loop. Basically, this connects from the top to the bottom, right? And what that means is that if you look at this situation, when we encounter F, and then we have a J that goes up. Basically, it actually, I may try a draw a little out. Okay, so here, when we go like this, right? In fact, this is we have a line that looks like this. Then this is a boundary that we are going to cross, right? Because it separates what is on the left and what is on the right. But on the other hand, if we have something like that goes like this, then actually things that is over here versus the things over here is still within the same thing, right? Whether you're in a loop, you're still in a loop. If you're out of the loop, you're out of the loop, right? But if you have something that goes up like this or goes connect the up top to bottom like this or connect to top to bottom like this, then we are actually crossing a border, right? If you are out, then you are in. If you are out, then you're in. Okay. So then I think we will. So for the horizontal, we are not going to do anything at all. And so from here, which means that if we encounter case L, then we need to know that whether we are crossing going up or crossing going whether the one that connects to this one, is it to the up connect it down, whether later on we will encounter something like a J or like a 7, right? Or we are just going to L and then a J to go up. So basically, if we're gonna have something like this, I think since we are gonna loop from row by row, right? Row by row, and then column by column from the left to right, then I guess if we will first encounter something like a L and F before encounter a J and a 7. So in this case, when we have L and F, we are going to say that we'll record whether we are coming from the top or coming from the bottom, and then later when we encounter a J or 7, then we will determine whether whether we are going across, right? So if we're coming from the bottom and then we're going on top, then we are creating a new border, which means we are crossing the border. But if we're coming from bottom and then we end up going back to the bottom, then we're not crossing a border, right? So so here I probably will create another flag, say from I think just call a from tile, right? From tile. And if this too, then I guess the from tile is the current tile. Just to record this so that later we will use it to compare in J and 7. So I think this is easier if we define a variable name. right? And because we know that this is a tile that is in a pipe loop, and we guarantee that we will have a loop, then if you connect from bottom to up, you come from anywhere, right? You come from here like this, then you're destined to will connect, go down, or you will connect up, so that you will eventually form a loop, right? So this is something that is sort of like guaranteed, so we don't have to think about that. We just we don't have to worry about the handle like some edge cases. So here we just say the from tile is this one, and then so that later on when we encounter J, we can determine how to handle this, right? And because we already say that we know that it is a correct tile, and then because we go from left to right, then we will definitely will encounter this, or like a this shape, or a this shape, right? This shape or this shape, definitely will encounter them from first before we encounter connecting like this shapes, right? Basically connect to the left shape, which is 7 and J. So we can here we can say save this from tile first, and then J and 7 we determine whether we are crossing a border. So, and then we can reset the tile to undefined, or we just keep it, it's okay. So the from tile, because later on if you come down again, you encounter the L and F first, right? You have to encounter L and F first before you can encounter a J and 7. So if you encounter a J, so then if from tile is equals to the one that is possible that we will J is connecting, J is basically connecting like this, right? So if we are having a F which is just going up, then we are creating a boundary. So if it's F, then we will swap the is in loop. But if we are L, then we are, whether you are in the group, then you are still in the group, if because this connects like this, right? So this is different from the outside world, right? We don't flip. But then if you connect like this, then most likely this side and this side is two different world. So if it's F, then the is in loop equals not is in loop. And for 7 case, when we go down, then the case of will be for L in this case, then we're gonna swap it out. And then it's in loop, it's not is in loop. Then I guess by this time we probably will already have this variable, right? And then if it's this will increment, then I think the logic wise most of the time I think we probably has done implementing the logic. Let's try and run and see what we get. We get 4, which is correct, right? In this example, it says that we have 4 tiles enclosed in the loop. I think that makes sense. Let me copy a slightly larger example and see whether we get the same answer as well. This is more a bigger example, and if we run, we get 9. And in this larger example, 8 tiles are enclosed by the loop, but we get 9. So something is wrong over here, and we need to figure out what is wrong. Oh my god. So let's see. I think one thing we can try to debug is that if it's in loop, when we want increments, let's print out what is the log and row and see which one is extra counted. So we have row 3 column 14, row 3 column 14, 1 2 3 4 5 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14, which is a L shape. Which is an L shape. I think it's tricky. No, so it's here, right? This is correct. Oh, I think something is tricky is because you have an S that we didn't actually account it for where what is S is supposed to do, right? Because if it's because this one, I think the example earlier on is we got kind of lucky because this two is the same. We don't have to change anything, right? We are in the same boundary. Outside is outside, but this one the S will probably flip something, right? Row 4, column 7, 8, 9, and 19, right? Which means from here, row 4, 7, 8, 9, and then 19, probably I'm guessing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I guess it's this outer one. We think that it is inside because we didn't flip this thing correctly based on what we have in S. I think this is the extra one that we calculate wrongly because of S. We don't know what is the boundary. So I think for this one, let's make some changes to our code, right? So if we think that we are let's see. I think we can. What we can do is that I think we can change this logic a little bit, right? Basically, we know that up is connecting. If down is connecting, left is connecting, right is connecting. Then we can know that this is basically connecting from the top to down, or top to left, top to right, or bottom to left, bottom to right. Yeah, all the different kind of possibilities, or left to right, right? So basically, we need to you create a flag call up. Okay, so okay, before that, I think then we will, instead of, then actually we can start with the starting point in our array, right? And then this we don't push anything, but we update the flag, and then we use this as a starting point to traverse through the whole thing. But before that, we'll check whether we are connecting up, down, left, right, and then we replace the content of the map of the starting point dot row column equals to get the value, right? Update, and then from there we will use this only point in the array to start traverse in the pipe loop. So in the pipe loop we can have just the starting point and column, and then because we know what angle, what tile this shape is, in our loop we basically able to follow through and then find out all the remaining tiles in the map, right? So here what we need is up, down, left, right, right? We were going to create a few variables. Let up equals to false, down equals to false, left equals to false, right equals to false. So this one, then I guess the up equals to this condition, right? And then I guess then in that case we don't even need to define a variable ahead, so we're gonna say down equals to this one, left equals to this one, right equals to this one, right? Something like this. And then here we can determine whether the tile get tile based on neighbor with the up, down, left, right. right? Get tile space on neighbor. So we're gonna define this function. So if up and down, then I guess it's a pipe, right? I think okay, let's with up first. If up, I guess we'll have all the combinations, right? So here, 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 here. Okay, so up down is this one, and then this one is if left and right. If top, up and right. So this is also up, but then up and left. These two are down, and so this one is left, this one is right. Okay, I think we are on a good direction. Let's try and see. Something wrong with our syntax. This one or return. There should be a semicolon. This should be a semicolon. Save this and let's run our code. Map. Setting equals to 12. Cannot reset. Hold on. What is this error? Let me see. Can this one map starting row, starting point column equals to cannot assign a read property 12 on a so because the map itself is this is a string, it's not an actual array, so we're gonna replace this character instead, right? So it's similar to this logic, but then because whatever comes here is actually a string, so we're gonna say string equals to I think let's create a function set map value, map left row column value, right? And then what we need to do is that map row is actually a string. Map row is gonna be string slice from 0 all the way to the column -1 plus the value plus the string dot slice column +1. So we replace this value where the row and column is. Okay, so this is gonna be our set map value. Let's find where was the logic over there. Yeah, here. Set map value, the map, the starting point row, the starting point column, and then finally the value that we want to set based on the tile, based on neighbor. And then let's save this. Let's run this again. We get 12. I think it's even worse. Okay, something is wrong over here. Let me see where we went wrong. First is that what is this value, right? It's F, right? F. Are we supposed to have an F over here? Seems like so, right? This connects up and connects down. Right? This is supposed to be an F. Then in that case, hold on, let me see. This one. I think we are right. Then let me console log the map to make sure that we are having the correct value of the map. Let's run this. Looks okay. And then also we kind of replace the row 1, 2, 3, 4, 0, 1, 2, 3, 4, F7, right? I think previously is L, hold on, L. This is a bit short now. I think we miss out one character. In that case, I think we are off by one. Oh, it's like this because this is not inclusive. So this is 0 to column exclusively without X column, and then this is the column value. This is the column plus 1. Save this, run this, and then we get 8, right? Which is the answer. That's correct. And then as you can see here, when we add, I think we don't add a new thing on row 4, which is correct. So let's remove some of the console log first because that may disturb our answer. Let's come back over here. Let's delete this and let's copy the actual puzzle in. Looks complex. Whoa! Can our code handle this logic? Let's come here and run. And then we get 511 and we're going to copy 511. We'll go back to the code and we are going to paste this value in and we are going to pray and pray, and that is the right answer. We got it. We get our another gold star and we are done with our day 10. We have accumulated 20 gold stars thus far, right? So thank you for watching this video, and please subscribe so that we are going to catch up on the next puzzle on tomorrow. So see ya. Bye bye.